Hello everyone, and welcome to this video. In this video I'm going to do a demonstration on our toolkit ReQue. ReQue basically is an extendable toolkit which gathers query refinement methods and generate gold standard datasets for supervised query writing methods. I'm going to start off with a brief introduction on the structure of our toolkit. You can see that ReQue has 4 stages. In the first stage, we do the query generation step, and for any input query in our dataset, a set of candidate queries gets generated for that query as the input of some expansion methods that we have here. And generally, there are 4 categories for query expansions: the semantic-based, lexical-based, embedded-based, and pseudo-relevance-based. And the main goal of our toolkit is to incorporate as many expansion methods as possible. And so far, we implemented 21 methods of expansion, and we chose these methods from different categories. And once we have the set of candidate queries ready, we can move on to the next step, which is the retrieval or search step. And so here we retrieve the relevant document from the corpus, and and we actually use the uncertainty toolkit to index our corpora and to run the retrieval. So it is necessary, and one of the prerequisites, to download this uncertainty format, and you need to actually represent it in as a subformat of this in this toolkit. And since we have the relevance judgment and relevant documents now, we can calculate the performance of search for each query, each candidate query that we have, and we can do actually a retrieval. The track eval, we're going to use this track eval tool to calculate the IR metrics for the retrieval of these candidate queries. And based on the value of the IR metric, we can see that which queries had improved the search, and those queries are selected as the gold standard datasets. So all the file organization, the prerequisites are mentioned in the GitHub link in the README file. So if you go to this prerequisite step, as I said, you should use this uncertainty to do the retrieval. You should use you should be able to see these prerequisites and packages for Python 3. And we're gonna use the conda environment to run our toolkit in this video. So these are the commands given to you, so you need to create those environments. And since there are some pre-trained models used in some of the expansion methods, here are the links. You need to download those pre-trained models, and you need to copy them into pre-subfolder as I showed. And the datasets that we use as the example to generate our gold standard datasets are the track queries, and here are the links to these corpuses. And before we start that, we actually use the uncertainty to index our corpus, and here are the commands to run the uncertainty for that purpose. And if you go to the query expansion subfolder, is actually where we're gonna run our code. We're gonna see these arguments. So these arguments are need to be used to construct our commands. So these are our running commands. For example, for robust 4, we can use this command. And let's actually go to our ReQue folder. So once you have it downloaded, if you go to this query expansion subfolder, you will see the expander folder. In this folder, you will see all the expanders methods of expansion that we have. If you go to the common folder, so there is one file called expander factory. Here you can see that these are all the method of expansion called here, but we're going to only use 2 of these methods for the purpose of this video, and the stemming ones, and here are all the relevance functions that we had, and we commented those out. And if you go to the main function, this is actually the core of our toolkit. So if we take a look at here, we can see that there are sub methods here: generate, search, and these are actually the stages of our I explained in our toolkit. And each of these are the sub methods, and these sub methods will be called in one method called run. This run method actually will call these methods as a pipeline, and the result of each will be saved in different file formats, and we're gonna see that later. So if we go to the DS, which is if we go to the pre, we're going to see that we have all these pre-trained models downloaded, and we have them there. And if you go to the DS, which is our data set, and if you go to the robust, you should be able to see the index, the QRLs, and the topics of these data sets. And once we have everything, once we done our example in this folder, you should be able to see the results of our data sets for each stage that I showed for each subfolder. So let's run our command. We're going to do on an example on robust corpus, and with the retrieval of BM25, and our methods of evaluation is actually mean average precision. So it starts to run. It will take a while to finish. So these are basically, for example, the first 2 are the result of the first stage that we had, and then for each stage, a result will be saved there. So after we generated our golden data sets, we actually needed to model some benchmark models, query suggestion models on our data set. So we used the sequence-to-sequence, ACG, and hierarchical encoder, hierarchical recurrent encoder-decoder methods. And to run those commands later, you can use this comments that we have there. And here is actually the link of the GitHub link of the implementation of those query suggestion models. And as we run as we model the benchmarks based on our golden standard datasets, we put the results in the GitHub link. And so here we can see that our run is finished. So you can see here are the results for each step. So you can see BM25, BM25 map, and finally the CSV files are our final data set. So let's open the first one, which is the result of the generation. So here is the candidate queries that we have. And in the second one, we can see the retrievals. You should see so these are the name of the documents retrieved for the first candidate query. And in the third part, so here is the mean average precision for each candidate query that we had. And finally, this is the final data set that we had. So you can see that, for example, for this query, this method of expansion actually improved the map, so we have them there. and import it there. So and bye.